Vehicle
Copy.
power changes in preparation for cruise stage separation. It's going to cut loose the cruise stage and all that solar array that's been powering us through all of cruise.
Pyro firing cards are now powered on. Go ahead, EDL com. So we're ready to switch the displays over to the 1010 marker, which will show EDL data manual tones. You ready? Standby 1. Yes, we are ready.
We're about 1 minute to cruise stage separation.
Tones should show up right now.
We're seeing the transition to tones now. The system should be configured shortly. And we're seeing carrier only.
The vehicle's changing to tones at this time. So we're switching from telemetry. We lost telemetry, and we're going to move to just tones.
EDA acquisition. They're showing a good strong signal, higher than expected carrier power.
Cruise stage separation. In about 1 minute, Curiosity's EDL software will wake up and begin final preparations for entry. The first action it'll take is to fire some warm-up pulses to get the entry RCS thrusters going. The pulses will ensure the spacecraft will get the thrust that we want when it's counting on it. Continue to receive heartbeat tones. Everything is good. At this time, Curiosity should be up to about 5.5 kilometers per second.
So what's taking place now?
So right now the vehicle is flying through space. It's actually in deep space still. In fact, not until after we hit the entry point will we actually begin to feel the force of the atmosphere gradually building on that heat shield. So really it's still a spacecraft. It hasn't actually become an aircraft. But we've checked out its rockets. It's actually used to turn the vehicle. It's turned to the right attitude, and that means it's ready to go. And as soon as we start filling the atmosphere, it'll start doing its role to get to the turn as part of the guidance that it does. It starts off with a right bank, and eventually will make a left bank, and then make another right bank as it makes its way to the landing site.
So it's a capsule right now.
It's a
headed
capsule.
in.
It's just a bare capsule. Nothing looking out. Just the radios is the only thing that's sticking out, and that's what we're getting. We're getting tones from that vehicle right this second.
Okay.
Now we're not getting Odyssey data yet. That doesn't happen until a little while later.
After parachute.
Actually, just after entry, just before parachute opens up.
Okay.
The first, when we're entering, this is a model of the entry capsule. When we enter the Martian atmosphere, usually we would have come in and just sort of hit the atmosphere squarely. But this time we have some extra weight on one side of the spacecraft, and that makes it fly at an angle of attack. And that angle of attack develops lift. And then we take that lift and we steer it back and forth, up and down, to steer our way through the atmosphere. What this allows us to do is it takes an uncertainty that we would have experienced in the landing footprint from hundreds of kilometers, at least 100 kilometers, and is able to shrink it down to 20 kilometers. This is something we need to do to land inside Gale Crater.
The vehicle is reporting that it has completed its turn to entry and spin down, and it has separated the cruise balance mass devices.
Okay, so as MSL approaches the atmosphere, we'll first have a straight shot of Earth looking backwards from behind us. Earth is to the left of that view. The great thing is, as it's coming in, we have two orbiters. You'll see them come into view in just a second. First, MRO from the south working their way north, and this is about the time that MRO is recording information that MSL is sending out to the world. At the same time, Odyssey which is coming in from the top part of the view, is listening to what MSL is doing. And right now, MSL is sending information through Odyssey, and Odyssey is repeating that information straight back to Earth. And that's what we're seeing in this room tonight.
At this time, Mars is actually pulling Curiosity in, and we're speeding up. We should be traveling around 5.4 kilometers per second on our way to about 5.9.
Affirmative.
The vehicle will switch antennas shortly. We'll have a short dropout when that occurs in the tones, switching to a tilted antenna that will be used through entry.
As
30 seconds to entry.
As we come up on entry, we'll expect a 2 to 3 second outage in the X-band signal as we switch from the ELGA to the TLGA.
We're switching to the TLGA, signal's dropped, and it's...
We just saw the signal drop. That indicates we changed antennas.
We're seeing heartbeat tones again after the switch. Things are looking good. We got tones back again. Coming up on entry. Vehicle reports entry interface. At this time, it will begin pressurizing the propulsion system to increase the thrust of the system. We'll use that for all the maneuvering in the atmosphere we're about to do.
Back heartbeat tones.
We are standing by for guidance start of guided entry.
Nav can see the entry in the atmosphere in the Doppler.
We are beginning to feel the atmosphere as we go in here. The vehicle has just reported via tones that it has started guided entry. At this time, the vehicle is beginning to steer its way to the target. It is starting its first bank reversal. First bank reversal complete. We have seen peak deceleration. We've passed through peak heating and peak deceleration. It is reporting that we are seeing Gs on the order of 11 to 12 Earth Gs.
Flight GDSA.
GDSA flight go.
We are processing data from Odyssey.
Bank reversal 2 is starting. We are now getting telemetry from Odyssey. Bank reversal 2 complete.
Copy, bank reversal 2 complete.
Thanks.
Standby flight. We have a connection, but we actually do not have any data yet.
Copy. We can expect some intermittent contact at this time as the signal gets
There we go.
increases to
Bank reversal
respectable
3
levels.
starting. We are now seeing telemetry from Odyssey.
Okay, copy.
And visualization is
We
updated.
have entered heading alignment.
There it goes!
At this time, Curiosity is no longer trying to control how far it's flying downrange and is just heading directly for the target.
End of range control, air used minus 1.2 kilometers.
Minus 1.2.
1.2.
The EL team is reporting that that things look pretty good at the end of range control. We have converged a lot of the error, and we should be heading for the target.
Flight EDL, TDS warning is okay.
Copy.
Power on.
We are seeing a tone from
the 1 gigahertz.
indicating that we have seen heating on the heat shield through the MEMD instrument. Everything looks fine. This is as expected. During this heading alignment phase, we're flying almost horizontally like a plane. We're going about Mach 2.4 at an altitude of 17 kilometers or so. Vehicle's reporting heartbeat tones again, indicating that everything is fine during heading alignments. We are standing by for straighten up and fly right and parachute deploy. Vehicle's continuing to decelerate. We're down to about Mach 2. As a reminder, we should have parachute deploy around Mach 1.7. We're at 15 kilometers altitude.
We've begun entry balance mass jettison. The predicted
Stand by for parachute deploy.
downrange is 1.597 kilometers.
EDL ops, Odyssey Systems on EDL ops.
Parachute deploy. Parachute. Thrusters have been re-enabled. We will control our attitude on shoot. We are decelerating.
Ritz mode under
Our 10 kilometers
parachute
decelerating
are 20
and
to
descending.
30
We are at
degrees
150
per
meters per second.
Dynamics phase. Come back again with wrist mode dynamics.
Ritz mode is nominal.
We are at 9 kilometers and descending.
active. Valid range.
Net filter converged with a velocity correction of 0.7 meters a second.
We've acquired the ground with the radar.
An altitude of 8 kilometers.
Feed chill has separated. We've found the ground.
Expand tones due to Earth occultation as expected.
We're standing by to prime the MLE engines in preparation for powered flight. We're down to 90 meters per second at an altitude of 6.5 kilometers descending.
Flight EDL, we got torpedo warnings. It is embedded towards low, so it should power to.
Director of Communications at this time. We may have lost it already. We're down to 86 meters per second at an altitude of 4 kilometers and descending. We've lost tones from Earth at this time. This is expected. We're continuing on Odyssey telemetry.
Ground solution equals minus 10.8 meters, vertical velocity of minus 82.8
We are priming
meters per second.
start enabled, standing by for back shell separation.
Signal to Odyssey is still strong.
We are in powered flight. We're at altitude of 1 kilometer descending, about 70 meters per second.
Signal to Odyssey remains
Down to 50 meters per second, 500 meters in altitude. Standing by for Skycrane.
Constant velocity accordion nominal. Altitude error 5.9 meters.
We found a nice flat place. We're coming in ready for Skycrane. Down to 10 meters per second, 40 meters altitude. Skycrane has started. Descending at about 0.75 meters per second as expected. Expecting final cut shortly.
Signal to Odyssey remains strong.
Tango Delta nominal.
Yep. You do a config.
Bridge stable. Bridge stable.
UHF is good.
Touchdown confirmed. We're safe on Mars. Time to see where our curiosity will take us.
This is Sparta!